Hello and welcome back to part 2 of 2.5 implicit differentiation, and we're asked to determine the slope of the tangent line to the graph of this equation. So again, this equation probably could be solved implicitly where it's y equals, but we're just going to do it as it's written. So remember that if I'm differentiating, remember I'm thinking dx, the differentiation in terms of x squared plus differentiation of x of 4y squared equals the differentiation in terms of x of 4. So remember, if they don't match, if the bottoms don't match of this, then that's where we have to do our implicit differentiation. So all our x and our x squared match, so I can just do the power rule, which gives me 2x squared. Plus, well, in this case, I have a constant multiple of 4, and when I differentiate y, I get 2y, but then remember, since y is not in terms of x, we have to add on our dy dx, saying that whatever this function is in terms of y is being differentiated in terms of x. And then over here, when we differentiate a constant, it doesn't matter, we get 0 for that one. I mean, it matters, but we end up getting 0. So don't forget that part. So now we have to solve this equation for dy dx, because that's what we're really asked to find, because they're asked to find the slope of the tangent line. So if I go ahead and do this, I'm going to subtract my 2x across the equal sign, 2x squared. Oops, it should just be 2x, shouldn't it? Sorry. It should be 2x. Subtract my 2x across the equal sign. Do that. And then I'm left with 8y dy dx equals a negative 2x. And then if I divide by 8y, I end up with what I really am looking for, my slope equation, dy over dx will equal, and if I reduce this, negative x over 4y. So there's my equation that I want for my slope of my tangent line. Now I get to plug in these x and y values up here into this to find the actual slope. So I'm going to move over here and do that. And so dy dx will equal this negative square root of x, square root of 2, square root of 2, negative square root of 2, divided by negative 1 over the square root of 2. And since we're dividing fractions, remember we multiply by the flip of the fraction. And, oh, it is 4 times that, so there's a 4 down here. Sorry, and so I multiply by the flip of that fraction, which will get me 2 on top, and the negative 4 stays on the bottom, because really I'm saying negative root 2 over 1, which is the top, times the flip of the fraction on the bottom, which is 2 over 4, root 2 over 4, which root 2 times root 2 is negative 2 over 4, which reduces to negative 1/2, which is the slope of my tangent line. And I seem to have lost a negative somewhere along the way. Oh, it was negative. Oh, whoops, whoops. Oh, there's my 2 negatives. They should have been canceled out. So this should have been negative, negative, and that should have been positive. So it should have been a positive 1/2. And so that's the slope of the tangent line at the given point. So sometimes you need to check and make sure you've got everything that you need. So moving on to the next example. And remember, as we're doing these examples, you can always come to class and ask questions if you don't really understand. So that's really what we're talking about here. All right, so I'm going to go ahead and differentiate this. And this one's kind of a bear, because we have a chain rule out here, so that's what's going to make this a little bit more of a problem. And over here there's a product rule. So here we have chain rule, and over here is product. So it's going to get us, this thing's going to get very ugly before it gets any better, so just bear with us here. So if we go ahead and do our implicit differentiation, I'm going to take 3, that's a constant multiple, and then I'm differentiate the outside, so the 2 comes out front, that's the power, and I leave the inside, x squared plus y squared. But then I got to multiply by the differentiation of the inside, which would be 2x plus 2y, and then don't forget that since I differentiated a y in terms of x, I get dy dx. So that's the first half, and then that equals 100 times, now this is a product rule, so remember for our product rule, f prime first, so we get y, 1 times y, plus, leaving the x, and when we differentiate y, we get dy dx. Oh, and so there's our terms, and so this thing's fairly ugly. So over here I can do a little bit of simplification. I've got 6 times x squared plus y squared, oops, that's supposed to be a square, times 2x plus 2y dy dx. And over here, I'm going to say 100y plus 100x dy dx. So I just distributed my 100 to that one. And so then, this is where the tricky part comes up, is trying to get the dy dx's all together. Well, I'm going to distribute this thing right here, to the parentheses, but I'm going to treat it all as one term. So this is where the trick comes up. And so when I do that, I end up with 12x times x squared plus y squared. So my 6 multiplied by my 2, and this thing right here multiplied by the x. So that's what I got. Same thing's going to happen with the y. I'm going to get 12 times x squared plus y squared dy dx. And then that still equals my 100y plus my 100x dy dx. So hopefully you can see what I'm saying by this thing getting uglier before it gets any better. So now I have to move my dy dx's across the equal sign, or at least to the same side, and anything that doesn't have a dy dx, this guy right here, is going to move across the other way. So let's see, so I'm going to subtract 100, so I'm going to leave my 12 times x squared plus y squared dy dx. Leave that guy alone. Subtract the 100x dy dx, and then that's going to equal my 100y, and then I subtract the 12x over here, which is 12x x squared plus y squared. So I get that, and then at this point, now you'll notice that on this side over here, I have dy dx in common, so I can factor that out. So dy dx factors out, and I'm left with this 12 times x squared plus y squared minus 100x, and that's going to equal 100y minus 12x times x squared plus y squared. So it's getting a little bit better. And then my final slope equation is dy dx equals, well, my 100y. Since this thing is being multiplied, this thing over here is being multiplied, I'm going to divide it across the equal sign. So my 100y minus 12x times x squared plus y squared all over 12 times x squared plus y squared minus 100x. And so that is my slope equation that I'm looking for. And basically, I get to plug in 3 and 1 for x to get my... So basically, I have 3 for x and 1 for y, and I got to plug those into this equation and get my final answer. So my slope, my y prime of this, is 100 times 1 minus 12 times 3 times 12, or times 3 squared times 3 squared plus 1 squared all over 12 times 3 squared plus 1 squared minus 100 times 3. And when all those numbers are crunched and tabulated and all that fun stuff, I should end up with 13 over 9. And so that's basically what we're trying to find, and that's the slope of the graph at that given point. Moving on to the next one, we're asked to find the second derivative of this function, and this is where it gets a little tricky, but this is our function. So first thing I'm going to do is go through and say, okay, power rule 2x plus 2y dy dx, because I differentiated a y, not an x, and then equals 0. So like all equations, I'm going to find out what dy dx is, and I do that by subtracting my 2x across the equal sign, and then dividing by 2y. That's an x. And so I should end up with negative 2x over 2y, which means that my dy dx, what I'm looking for, dy dx, is negative x over y. Well, they don't want the first derivative, they want the second derivative of this. And so I need to do the second derivative, which means that I get to do this all over again. And so this is, remember, this is y prime, so I'm going to call this y double prime. I'm just going to go through and do this. And so I could, if I wanted, if you'd rather, you could do it as a product rule. But I'm going to just do it as a quotient rule. So differentiation of the top leaves me -1 times the bottom minus leave the top, so that's a negative x, and then differentiate the bottom, dy dx, all over the bottom squared. And so now I get to simplify this a little bit. Y double prime is -y plus x dy dx all over y squared. Now I could write this as y double prime is -1 over y plus x over y squared dy dx. And so at this point I have a little bit of an issue because I need to figure out what dy dx is, but they gave that to me. We did that earlier when we found out that dy dx over here is -x over y. And so that's basically what I'm going to do, is I'm going to plug in negative x over y for my dy dx. And so at this point I end up with my y double prime being -1 over y plus x times y squared times -x over y. And so I can then get this all kind of together, and so y double prime equals -1 over y plus, or actually minus x squared over y cubed. And say I picked a point, -3, 4 for this to find the slope at this point. Now I can just go ahead and plug them in, and I'm left with y double prime equals -1 over 4 minus -3 squared over 464. And so with a little bit of work here, y double prime will come out to be -16 minus 9 all over 64. And so I should end up with -25 over 64 for the slope at that given point. And that's really what we're looking for when we're doing these problems. So then my final example for today is I want to find the tangent line to the graph of this given equation. So they're looking for the tangent line, so we're looking for the equation of the tangent line is really what we want. And so we have to go through and do product rule and stuff like that. So let's get to it. So product rule for the beginning, because I see an x squared times this thing. So differentiate the outside gives me 2x. Leave the inside alone. And then I leave the outside alone and differentiate the inside, which will give me 2x plus 2y. But now since I differentiated a y, I get my dy dx. And then equals 2y dy dx. So I'm going to leave this guy over here. I'm going to leave this thing alone because there's really not much for to do with it right at the moment. This thing I'm going to distribute my -x squared so I can get rid of the parentheses. And so when I do that, I have my 2x times x squared plus y squared plus 2x cubed plus 2x squared y dy dx. And you may see why I'm doing this is so that I can get my dy dx's kind of together. And so I'm actually going to subtract this one across the equal sign, just a little less work for me. So 2x times x squared plus y squared plus 2x cubed will equal 2y dy dx minus 2x squared y dy dx. So now I've got my dy dx's together on the same side. And that's really all I'm going to do is try to move them across the equal sign, but I'm going to do a little factoring first. And that's what you see happening here. factored out my dy dx. And then now I get a divide, so I'm going to divide both sides by this thing on top. And so when I do that, I end up with my final slope equation of 2x x squared plus y squared plus 2x cubed, all divided by 2y minus 2x squared y, equaling my dy dx. And so that's really what I get here. And when I do that, now I can go back and plug in the points they gave me to find out the slope, because that's really what I want. So it's 2 root 2 and root 2 over 2. So it's, let's see, 2 root 2 and 2 over root 2, I believe, were the 2 points. I'm just writing them down here. So, oh, it's root 2 over 2. This guy right here is root 2 over 2. I'm just writing them down here just so I have them, because I don't need to be looking back every time. So now I'm going to plug them in. So it's going to be 2 times 2 root 2 times 2 root 2 squared plus root 2 over 2 squared plus 2 times 2 root 2 cubed, all divided by 2 times root 2 over 2 minus 2 times 2 root 2 squared times root 2 over 2. Well, that's kind of a mess algebraically speaking, but remember that this is the slope is what I'm looking for. And so with a little bit of simplification here, let's see, and these guys were multiplied by that thing. So, all right, let's see. 2 root 2 squared becomes 4 times 2. So I've got 2 times 2 root 2, which actually, hold on, let's go back. Let's try to simplify this a little bit more. I'm going to make this 4 root 2 is just multiplying these guys together, these two together. The next one, when I square this thing, I'm going to change colors. This guy squared becomes 4 times 2, which is 8. This guy squared becomes 2 over 4, which is a half. Yeah, 2 over 4. And then over here, this becomes 8 times 2, which is 16. And there's another 2 times 2 times root 2. So that's all of that part. And then on the bottom, well, these 2's cancel out, so I'm left with a root 2 on the bottom. Over here, I have my 8 again, so it's minus 2 times 8. And then this guy, the root 2 over 2, will cancel out the 2's, so I'm just going to get rid of this 2 and call it root 2. Alright, so there's my denominator. And so this thing's pretty ugly looking, and it's just a matter of kind of crunching all this together. And with all of this, it should come out to be 3. And so that is the slope of my tangent line, and you can do all the simplification. That's the slope of my tangent line. So if I want my equation of my tangent line, I'm going to say y minus, and then my y was root 2 over 2 equals 3 times x minus 2 root 2. And actually this is okay for the equation of the tangent line. If you need to simplify it further, then you will find out that this thing will come out to be y equals 3x minus root 2. But I would just go through and I would stop right there. That's fine enough. That's all we really need to know. So thank you for listening for the part 2 of implicit differentiation. Very important section, and make sure if you have any questions you please ask them in class. Thank you.